Get the most out of the Python standard REPL. The Python standard shell, or REPL, Read-Eval-Print Loop, allows you to run Python code interactively while working on a project or learning the language. This tool is available in every Python installation, so you can use it at any time. As a Python developer, REPL sessions are hugely valuable because this tool allows you to test new ideas, explore and experiment with new tools and libraries, refactor and debug your code, and try out examples. In this course, you'll learn how to run the Python standard REPL or interactive shell, write and execute Python code in an interactive session, quickly edit, modify, and reuse code in a REPL session, get help and introspect your code in an interactive session, tweak some features of the standard REPL, and identify the standard REPL's missing features. You'll also learn about available feature-rich REPLs such as idle, IPython, BPython, and PTPython. To get the most out of this course, you should be familiar with your operating system's command line or terminal. You should also know the basics of using the Python command to run your code, as seen in this real Python course. However, following along is often the best way to learn, so see how you get on, and if you need to, you can always refer back to this course later on. So now you know what's going to be covered, let's get started. Getting to know the Python standard REPL. In computer programming, you'll find two kinds of programming languages: compiled and interpreted. Compiled programming languages, such as C and C++, will have a compiler program, which takes care of translating the language's code into machine code. This machine code is typically saved into an executable file. Once you have an executable file, you can run your program on any compatible computer system without needing the compiler or the source code. In contrast, interpreted languages such as Python need an interpreter program. This means that you need to have a Python interpreter installed to run Python code on your computer. Some may consider this characteristic a drawback because it can make your code distribution more difficult. However, in Python, having an interpreter offers one significant advantage that comes in handy during your development and testing process. The Python interpreter allows for what's known as an interactive REPL, Read-Eval-Print Loop, or shell, which reads a piece of code, evaluates it, and then prints the result to the console in a loop. In this course, you'll learn about the CPython standard REPL, which is available in all of the installers of this Python distribution. If you don't have CPython yet, then check out the Python 3 installation and setup guide for detailed instructions. The Python interpreter can execute Python code in two modes: script or program mode, and interactive or REPL mode. In script mode, you use the interpreter to run a source file as an executable program. In this case, Python loads the file content and runs the code line by line, following the script or program's execution flow. By way of contrast, interactive mode is when you launch the interpreter and use it as a platform to run code that you type in directly. The name Python is commonly used to denote two different things: the language itself and the interpreter. In this course, you'll find the explicit term Python interpreter only in situations where ambiguity can arise. When you run the Python interpreter in interactive mode, you open an interactive shell, also known as an interactive or REPL session. In this shell, your keyboard is the input source and your screen is the output destination. In this course, you'll find the terms interactive shell, interactive session, interpreter session, and REPL session are used interchangeably. The input consists of Python code, which the interpreter parses and evaluates. After that's done, the interpreter automatically displays the result on your screen, and the process starts again as a loop. So, Python's REPL is an interactive way to talk to your computer using the Python language. It's like a live chat. The whole process is known as a REPL because it goes through 4 steps that run under the hood. Reading your input, which consists of Python code as expressions and statements. Evaluating your Python code, which generates a result or causes side effects. Printing any output so you can check your code's results and get immediate feedback. And looping back to step 1 to continue the interaction. This feature of Python is a powerful tool that you'll wind up needing in your Python coding adventure, especially when you're learning the language or when you're in the early stages of a development process. That's because the REPL offers several benefits, which you'll learn about next. As a Python programmer, you'll spend considerable time in interactive mode. This mode provides a quick way to try out ideas and code snippets, and in a REPL session, you can do some or all of the tasks seen on screen. As a Python developer, you'll have many reasons to spend a lot of your time in REPL sessions working interactively with the interpreter. Getting immediate feedback on how your code works is the most relevant benefit of using a REPL session. Interactive mode is one of the best features of Python. It allows you to test solutions and experiment with the language in real time. If you want to know how something works, then just try it in an interactive shell. You should consider the interactive shell as a powerful learning tool, especially if your previous programming experience has been with compiled languages that don't provide a REPL. While learning Python or exploring new features and concepts, you'll note that many examples in the Python documentation, online tutorials, manuals, and courses are copied and pasted from an interactive session. You'll recognize them because of the REPL's characteristic prompts, which you'll get to know later on in the course. With this introduction to interpreters and REPLs under your belt, you're ready to get into action. In the next section of the course, you'll learn how to start and end a Python interactive session. Starting and ending REPL interactive sessions. The Python standard REPL is available in every Python installation. To start a new session, you just need to run the Python interpreter in interactive mode from your command line. This mode will put you into a shell environment where you can execute Python code. Learning how the input code works is a way of getting immediate feedback on it. Once you've installed Python on your computer, then you can immediately start benefiting from this tool. To start a Python interactive shell or session, open a command line window and run the Python command without arguments. This command makes Python enter its interactive mode. The interpreter will run, and you'll get an output similar to what's seen on screen. The first line of this output shows information about your current Python version and the platform on which you're running it. The second line shows a message with commands that you can run to get additional information about Python in general. The last line shows the primary prompt of a standard Python interactive session or shell. By default, this prompt consists of 3 greater than signs, also known as chevrons. Its purpose is to communicate that the interpreter is ready to accept input. The interpreter also has a secondary prompt represented by 3 dots. This prompt appears when you're entering compound statements or line continuations. You'll learn more about this later on in the course. Now that you're in the Python REPL, the next question may well be how you get out. If you're used to working on your command line or terminal, then you probably don't like closing and opening terminal windows all the time. Your regular workflow may go through executing CLI tools, closing them when the work is done, and then returning to your current shell session. Once inside the Python REPL, you can't run normal shell commands because you're inside a different environment. To get back to the normal shell, you need to terminate the REPL session. There are a few different ways to do this. You can either use quit or exit. These 2 functions are built into Python. Therefore, they're available to you at any moment in an interactive session. Both functions allow you to exit the current session by implicitly raising a system exit exception. You'll see other ways of exiting the REPL later on. The Python command can take a number of command line options. A few of them can be useful when working in a REPL session. The C command line option allows you to quickly run a Python statement or expression that you provide as a string on your command line. Try out the command that's seen on screen. One of the most relevant options in this context is the I flag. This option makes the interpreter enter the interactive mode after running a script or executing a piece of code using the C option. You can use the I option to check the current global variables in your script or to inspect the stack trace when your program raises an exception. To try this out, let's say you have the script that's seen on screen. This script reads some sample data for a file or database and provides a function to compute the mean or average of the data. Run the script with the command seen on screen. Once you press enter, this command runs the code in sample.py and takes you directly to an interactive session. You'll recognize this session because your screen will present the REPL's primary prompt. From this point on, you can inspect, test, and debug the code in sample.py as needed. First, you call the built-in globals function to inspect the global names defined in the script. This function returns a dictionary that maps names to their corresponding objects. Next, you call mean with a new sample of data. Note that when you run a piece of code in an interactive session, you typically get immediate feedback as an output on your screen. You'll recognize the code's output because it won't have a leading prompt. Finally, you call mean with an empty list as an argument. In this case, the function fails with a zero division error because calling len with an empty list returns 0. Note that when you use the I command line option with the Python command, the Python startup environment variable won't be read. You'll learn more about this environment variable later on in the course. The B flag is another command line option to consider when you run Python in an interactive mode. This option comes in handy when you're running code that compares bytes objects and you want to get a warning if a string or integer value gets in the middle of a comparison. The B option seen here makes the interpreter display a warning when it finds operations that compare bytes with either strings or int values. If you don't use this option, then no warning is seen. As seen previously, the comparison returns false because the values are of different data types. However, here you don't get any warning that helps you understand why you're getting this result. This is just a sampling of the options that may come in handy when you're using Python in interactive mode. For a complete list of command line options, check out this Real Python course. Earlier you saw that you can use exit or quit to leave a REPL session, but there are other methods available to you. Some you may use every day, others you may only see or use occasionally. A quick option for terminating a REPL session is to use a keyboard shortcut which will depend on the operating system you're running on. Ctrl-D on Unix systems such as Linux or Mac OS, or Ctrl-Z and then Enter on Windows systems. These key combinations represent the end of file character in the corresponding operating system. They allow you to exit the current interactive session because the interpreter runs in a special file called dunder main, as you can confirm by inspecting the dunder name attribute. All the Python code in an interactive session will be contained in the dunder main file, which runs until an end of file character is read. This means that when the interpreter finds this character, it immediately terminates the current REPL session. Alternatively, you can explicitly raise the system exit exception manually with an exit code of 0. You'll get the same result and your current REPL session will terminate. Any of these methods will get you out of your current Python interactive session and take you back to the operating system shell. After this, you can run regular commands once more. In the next section of the course, you'll look at how to run code within a REPL session. Running code in a REPL session. Up to this point, you've learned what a Python REPL is and why Python developers love it. You've also learned how to start a REPL session using the Python command and some of its command line options. Also, you've learned how to terminate a Python interactive session, jumping back to the operating system shell. In this part of the course, you'll learn how to enter and execute Python code in an interactive session. Once you've launched a Python interactive session from your command line, you can start entering and executing Python code immediately. To do this, get back to your command line window and run the Python command. When the REPL's primary prompt appears on the screen, type the expression seen on screen, pressing the Enter key after each of them. This first expression subtracts the two numbers and displays the result. The second expression is a call to the built-in sum function, which takes a series of values and returns the total sum. Here, you execute a Boolean expression that compares two numbers. And this example uses an assignment statement to define and initialize a variable called number. Because assignments don't return any value, the Python interpreter doesn't display any output on your screen, and instead it falls back to the primary prompt immediately. And this shows how Python displays an error when your code has issues. While running these examples, note how after executing each expression, the interpreter loops back to the primary prompt, which lets you introduce a new expression. Now you've seen the REPL cycle in action. The Python interpreter has read your expressions, executed them, and printed their corresponding result to finally loop back to the primary prompt. With the examples in the previous section, you've executed simple statements in a Python interactive session. These expressions are known as simple statements because they don't have an indented code block. Python also has compound statements, such as conditionals, loops, and with statements. Compound statements require an indented code block. The Python interpreter has a secondary prompt that lets you enter the code block of compound statements. Take a look at the example seen on screen. Here, you first define a variable to hold a number. Next, you start a conditional statement. Once you type the colon character and press Enter, you get 3 dots on your screen. These dots represent the REPL's secondary prompt. This prompt on your screen means that you can enter the required indented blocks of your current compound statement. Note that to break out of the REPL's secondary prompt, you must press Enter twice. This action takes you back to the primary prompt. When it comes to entering indented code blocks, keep in mind that the standard REPL doesn't support auto-indentation. In the Python standard REPL, you must provide the appropriate indentation manually for any indented code block that you need to enter. Otherwise, you'll get an indentation error, as seen on screen. Another situation where the REPL's secondary prompt appears is when you need to use line continuations. A line continuation occurs when you explicitly join multiple physical lines into a single logical line using the / character as seen on screen. This assert statement performs 2 checks on number. First, it uses the built-in isInstance function to check if the value is an integer. Next, it checks if the input value is greater than 0. If either of these conditions fails, then the statement raises an assertion error with the provided message as an argument. Line continuations also happen when you use several physical lines to write an expression delimited by a pair of brackets. For example, when you define a list, tuple, or dictionary. Once you use opening brackets, braces, or parentheses and press enter, you get the REPL's secondary prompt. This is known as implicit line joining. You can also use implicit line joining in other contexts, such as mathematical and Boolean expressions, function definitions and calls, list comprehensions, and generator expressions. In short, implicit line continuation will appear in all those Python constructs that accept brackets, braces, or parentheses. When you run Python in interactive mode, you'll note that the interpreter immediately displays the resulting value of evaluating or executing any expression or statement. This is true for all the statements and expressions that generate a return value. The interpreter doesn't display anything for statements that don't generate return values. That's the case with assignment statements, as you've already seen. The Python interpreter behaves this way because its primary goal is to provide immediate feedback on how your code works. This behavior makes using the built-in print function almost unnecessary when you're working interactively. However, there's at least one use case for print in REPL sessions. You'll need to use print when you want to display the result of an expression or statement that can or will return none. For example, a common error that some Python beginners make when they start to learn about lists is to expect new lists from calls to list methods such as append and sort. Because these method calls don't issue any output to the screen, it may seem that they didn't perform any actions. However, they did. Most list methods run their intended transformation or computation in place. In other words, list methods often modify the underlying list object instead of creating a new one. Because of this, they return none, which the REPL automatically ignores. As a result, nothing shows up on your screen. If you ever need to display none in a REPL session, then you must use the print function. Here, you use print to show the return value of append, which is none. Note that you can always access the content of a given variable by typing the variable's name and pressing enter after it, as you did with numbers. However, if the variable is currently set to none, then you won't get anything on screen. You'll need to use print, as you can see here with value. In the next section of the course, you'll deepen your understanding of running code in the REPL, looking at errors, special variables, and how to reload imported modules.